Part of what makes FRS work is to associate specific energies of X-rays with specific elements. How are the different X-rays generated? Well, this question relies on you knowing that characteristic X-rays are generated through the, if this is the nucleus, and this is not to scale, so that we've got protons and neutrons in here, the characteristic X-rays are generated through the transition of electrons in the inner core shells of the atom. So imagine this is n equals 1, the first shell, or the K shell, n equals 2, and this is n equals 3. These are principal quantum numbers here that I've drawn out. So the characteristic, the specific energies of X-rays are produced by having an electron first of all, knocked out of, I'm missing the electrons, so I'll make the electrons red. 2 in n equals 1, there's 8 in n equals 2, 4, 5, 6, 7, 8, and n equals 3, there's, let's see, I think 18. I'm not going to draw them all. You can imagine they're out here. So in what produces the K alpha X-ray, so this is KeV, the energy, and this is intensity. And by the way, intensity means the number of photons with that particular energy. You see that this, we're going to call it K alpha, and there's going to be a K beta. These two K emissions come from, first of all, an incoming photon knocking an electron out of the inner shell, so that we're left with a we're left with one of these missing, essentially a missing electron from here, because that gets knocked out of the inner shell, and that's replaced by either an electron from this level falling down and emitting an X-ray in the process, or one falling down from a higher energy level like this, dropping down and then emitting the radiation required to drop down into that level. In this case, this would be K beta, and in this case, this would be K alpha. So this process happens in the inner core of the atom. So if we were actually to step back from that, we know that compounds really, if we look at the whole atom, again, this is not to scale, compounds occur at the scale of these interacting outer shells that alter the energy level here. And characteristic X-rays occur at the level of these inner shells that actually can't really see each other. I could draw a set of equivalent electron shells here inside this atom. That's what I'm representing here. So these different X-rays are generated by these transitions on these inner levels, and in a sense, this happens for an isolated atom the same way that it would happen for an atom that is in like a diatomic molecule, or even if it were in a larger crystal where we have many atoms, because really only the outer shell electrons interact with one another, and that is what causes things like the conduction band and the valence band, whereas these inner level electrons are really, their energies are unaffected. These electrons don't really know that these electrons exist, so to speak.